Welcome to our presentation, and today we're going to talk about a bit of practical stuff about how to build a data warehouse for different learning analytics project. We've been doing quite a while research in learning analytics, and suddenly we were in the position that everything around us changes. And for example, for us, the university changed our LMS. You found yourself confronted with new technologies. For example, in the couple of years ago or now, VR and AR as technologies are basically emerging, and also multi-touch tabletops and also eye tracking projects emerge. And basically you're doing research in all these environments, especially in the learning environments, and you have such research projects, and you always come to a situation, what do? You basically, whether you go ahead and follow the traditional approach, so you get a person that does everything for you, or you basically take this challenge as an opportunity to create something new and to create something sustainable. And we have faced this challenge several times, and we actually decided, let's take the opportunity and build something that we can basically reuse in different research projects. And our idea is basically to build an integrated multimodal data warehouse where we all store our research data, and we focus more on basically doing research and not building technical infrastructures over and over again. And these are basically the typical elements of analytics projects. It always starts with a question, and then in order to answer these questions, we collect a lot of data from different sources, from different tools. We analyze these data, we do some magic with it, and in the end, we have some new knowledge. And in many cases, you need a person that actually, or more person that actually can take this data and your question, do a lot of things to it, collecting, transformation, and analysis and visualizations. And then they provide results to you, and then you basically build knowledge on top of this data. And all this black box magic actually has three components. And the first one is the data collection and management strategies. And here, basically, whoever is working on these analytics projects needs to build a technical infrastructure for the data management. And this means set up all the databases, set up all the network channels, set up all the data collection strategies, then build the different data scrapers and analyze the shapes and collect this data and transform the data and save it to a database. And in this process of collecting data, this person has to do a lot of cleanup, because although many tools and many data sources do collect data, they collect it in a unique way. So you have to clean it up, you have to transform it, you have to aggregate it and save it into a database, or a data warehouse, or a data lake, or persistent storage, and sometimes it's just simply CSV files. And in this part, you actually need to take care that the data is always available for analysis, and it's accessible in some sort of a way, either via direct database connection or via an API, whether it's RESTful or some other kinds of APIs. And whenever you have a lot of data coming in or a lot of data stored, you need to take care of the scalability. So for example, when 2, 3, 4 people try to access a lot of data at the same time, and then a lot of data is coming back in from the experiments, you need to take care of the safety and security of the data, so you don't have data leaks. And in the recent years, we had some work done in this area, especially with GDPR. So you need to take care that the data is collected in a legal fashion, and all these things fall under the topic or under the issue of data management. And then after you've set up your technical infrastructure and you have your data pipelines that collect and transform data, the next step is you need to analyze the data. And to do this, first of all, you need to understand the data format in which your data is saved. You need to understand the data, basically the warehouse model, how the data or the data storage is constructed, and you need to read the data or simply access the data. The next step, after you've learned all these things, you have to basically devise your own data analysis strategies and algorithms. I mean, there are a lot of pre-built tools available out there, especially in ScienceKit for Python on pandas, or you build your own analysis algorithms. And after you've basically accessed the data, you've chosen your methods how to analyze your data, and then you receive some results, and you need to save these results, and you need to save these results somewhere so you can build knowledge on these results. And the third step of an analytics project is basically presenting your results. And this also means, again, doing a bit of technical work where you load your analytics results from a results storage, and you define and design your analytics indicators, and you visualize the results. And our experience has shown that around 80% of the work actually happened in the first part that I explained. And this is basically the data collection and management, and the first part of the data analysis, basically understanding the collect and raw data. And this is something that we as a research group, and especially me and my colleagues as developers, we have struggled with, especially in working on dissertation on our research project. So every single one of us had to implement this, had to design it from scratch. And this is work that can be avoided. And this is work that can be done once, and it can be done for everyone else. And the basic ideas for our contribution is basically, we want to share our practical experiences in implementing such technical infrastructure, which stores all these learners' data from different projects. And we hope that this will reduce the effort for researchers, and they have more time to actually concentrate on running experiments and building value and knowledge, and not basically tinkering in the background just to collect the data. And our scenarios that we have in our research projects, they actually include different types of tools and different types of hardware. So we have virtual reality projects that they use virtual reality headsets. We have eye tracking equipment. We have multi-touch tabletops. Of course, we have also the learning management system. We have projects that use a lot of mobile devices, and also projects that generate a lot of physical experiment data in a lab. And all these different projects, all these different data sources, they actually generate a lot of data. And they generate these data in different formats. And I know in the recent times, data lakes have been prominent, but in our scenario, data lakes is a very undesirable solution, because it does not really take the overhead of researchers. It just simply puts all data in one place and tries to make it available to everyone. And to give you some ideas about what kind of events that we need to take care of, for example, from the projects, we need to store learning management system interactions. We use Moodle as a learning management system now. We have a lot of virtual reality events and learning and interaction events. We need to combine also performance data from Moodle. We need to collect experiment data from physical labs. On the other hand, we have multi-touch tabletops, and we collect multi-touch events for each individual learning, including timestamp that has a session identifiers or tangibles. We have interaction events that try to picture the success or failure rate of each interaction, the drop area. We have scores and feedback events, which include learning context from multi-touch learning games. We have context game data, so whether there is teamwork, whether there are cooperative events, whether it's a collaborative game or competitive. If we talk about eye tracking, we have remote eye trackers that basically are stationary eye trackers that allows actually us to gain a deeper understanding of multimedia learning in traditional learning management systems. We are tracking eye movements in virtual environments. We're tracking we're tracking or classifying collaborative interaction when doing multi-touch learning games in multi-user scenarios. So basically we're combining eye tracking with multi-touch. And since we have so many different events from so many different sources, we actually decided that we need to go in an abstraction higher and choose some data standard that can actually help us classify and store all these events. And we've chose Experience API as an underlying data standard for our scenarios. But just choosing Experience API in itself doesn't actually bring much. And it is just basically a way how to do event notation or events description. And to store all these events or these activities, we need to basically design a data warehouse. And we've chosen, as I said, our Experience API data standard as an underlying data model. And since Experience API has this actor verb object structure of the events, we need to develop suitable vocabulary which describe all the events from all the scenarios. The next step that a data warehouse has to have, it basically have a standardized access for data analysis. So in our case, we chose RESTful API, so it's available over the internet. And we have enough persistent storage and data availability in the whole scenario. So different researchers can access the data in different points of time, either for analyzing or for storing new events. And for basically to build our own data warehouse, we developed some criteria which we use to choose and to analyze what kind of learning record stores are available there and what kind of warehouses we can use. And we developed our set of criteria by which we evaluated those learning record stores. And first of all, we needed to take care of the license, and we needed a license in the spirit of GPL because it should not incur additional costs for us. We are an open, we are a public institution, and we need to have a license that does not have additional costs. And for our scenarios, Creative Commons or MIT or BSD licenses were more restrictive, so we went with a license in the spirit of GPL. The next thing is that one needs to take care is the type of service. And for us, self-hosted was the best option because it provides complete hardware and software control over the infrastructure and the data. The third point that we discussed is the data standard, and for the most suitable solution for us is the Experience API because it's an open standard and it can be extended to fit into the different scenarios. It is really important to have a very scalable solutions, because for now we have 4 or 5 scenarios, and in each scenario we have at least 4 different modalities for the data sources. When all of the generated data is combined together, a lot of physical data is generated, and the warehouse has to be easily scalable to handle these amounts of data, especially horizontal scalability. And it is a must because it must be easy to add new physical servers or data storage on the fly, because we have a lot of data that is generated from these different projects. The next thing, when you have a lot of data, your whole technical setup needs to be really performant, because it must be able to analyze and support concurrent use whenever different projects are running. It must support concurrent analysis, and it needs to basically deliver results over network, because not all projects happen offline or have direct connection to the learning record store or the warehouse. On the other hand, since we're doing a lot of, our research is open and we need to share it, and our goal is basically to provide back to our research peers and community and share our work. And when you have community behind your technical implementation, it's always easier to debug and fix if something goes wrong. It is also very important to choose a suitable technology stack, which is homogeneous and open, because well-known technologies are easier to develop, they're easier to upgrade, they're easier to maintain. And as a long-term solution, this is something to think about. The next thing, since we're in the European Union, we need something that will take care of the data privacy aspects. And since many learning record stores should already have some implemented and integrated mechanism which make data privacy conformant in Germany and the EU, and this means that some of the features have to be built in that follow the rules from the state, that follow the rules from the federal data privacy laws, and of course on top the EU's GDPR. Since we are working with personal data, we should have a basically safe and reliable way to authenticate components which allow users, devices, and systems to basically safely and reliably access the storage of the learning events. And this is a really hard environment because we have distributed environments, we have different systems, and they need to be able to safely authenticate and are authorized to store and read data from the events. Since these are research projects and new technologies and new projects always come in and go, it is important for future integration of new projects and new learning events that the record store or the warehouse is extensible, so new projects can always come in. And the last thing that, the last criteria for our learning record store is basically the up-to-date factor. And this is important factor that shows how well the infrastructure is updated or used within the community of researchers and practitioners, since our ultimate goal is that our research would at some point in time be deployed in a real scenario, so it doesn't remain a research project. And once we've considered all these criteria, we chose to run the Learning Locker, the community edition. So basically we have a local instance of it installed at our own servers. We are hosting it on virtualized Linux machines, so we don't have any license costs. We do our administration by ourselves, and we always use open source administration tools and technology stack. We've designed our hardware basically to be scalable and performant. We've achieved horizontal scalability because we can add virtual hardware on demand whenever we have a lot of events. We have designed multiple workers and instances which basically do a lot of parallel processing of the queues whenever events are coming in or going out. And we use Mongo indexes and aggregation API for the persistent storage. And the whole setup is relatively easy to use once you get to use it, and it's extensible via the web interface, and administrators can build different dashboards that do various reports on the events being stored in the warehouse. Moreover, it can be extended via connectors, and the raw data itself could be exported. Of course, not everything runs smooth in our implementation. We actually struggled with Experience API and its use, because the current registries that offer verb lists and activity lists, they actually focus only on MOOCs and regional learning management systems. But our needs are more than that, because we have multi-touch learning games, we have virtual reality, we have apps, and we have handheld devices, and we need a different set of verbs and activities. Moreover, most registries actually link to broken verb and action activities definitions. So this is something that we need to resolve. And we actually devised a plan to avoid new insular solutions. So we designed our Git repository for Experience API profiles and vocabulary. And our plan is to open it to researchers, so to long-term stakeholders, so researchers, and we want to invite them as repository maintainers. And the short-term stakeholders in our case, so the developers or companies that would like to use our Experience API registry and repository, they can actually fork and pull request our verbs. And we want to do the entire thing open, and we want to update it or extend it as more people come on board with us, and we use GitLab's continuous integration to actually generate the automated documentation of new verbs and activities. And this brings me basically towards the end of my presentation. What actually we have learned while trying to develop this data warehouse with Experience API as an underlying data model. First of all, what you need to take care of, researcher or as a technical guy, is to identify your use cases, and you need to order your priorities. So you really need to take your time for the requirement analysis. And I cannot stress this enough, because if you're trying to build something big and something big that should run projects for the next five to 6 years, you really need to talk to all potential stakeholders to see what actually want to do with data. The second thing is you really need to use a technology stack with a scalable backend and that has good community. And you need to think big and think ahead. So, because a lot of events will come and this is the next point. So take care of storage and bandwidth, both upstream and downstream. So we've had experiments that actually generate up to 10 megabit of data upstream of events. And all this data had to be transferred remotely to our learning record store. And sometimes we were actually struggling for upstream bandwidth. So you really need to plan your hardware, and you need to talk to your basically network infrastructure provider early, so you have a stable gigabit connection to your learning record store. Because if you have several projects generating thousands and thousands of events, you will run into a problem into saving all of them. The next part that is that you need to communicate towards all the researchers or all the people that want to use your data warehouse is get to know the nuts and bolts of Experience API and its specification, because you really need to get a deep understanding of what you need. And for example, Experience API does not really support deleting statements. Instead, you need to actually generate a new statement that makes a previous older statement void. So this is something that your developers need to do or need to understand whenever writing some events in your warehouse. And the last part that is often omitted is you actually need to have a very good deployment maintenance strategies. And you need to plan this beyond yourself, because if you have multiple people working on multiple projects, or you have batch jobs that analyze data, and if you don't plan your maintenance correctly or your deployment, you're basically ruining someone's experiment. And this is something that you should try to avoid, because all of us have deadlines, all of us wants to have good analytics results, and we want to basically support everyone in providing good research and good analytics results. So thank you for your attention. Do you have questions?
Thank you very much.